Hello everyone. I am going to talk to you today about greatest common factor. We abbreviate it as GCF. So first we're going to learn how to find greatest common factors of a pair of numbers, so that it could be more than just two, maybe three, whatever. This method would work either way. But let me explain first of all what is the procedure. So the first thing you have to do is list all possible factors of a given number. So let's say it's 12. What do? Well, you start with the number 1 because 1 is always a factor of anything. Okay, so 1 you start. What does it mean, a factor? Well, if I divide them, do I get a whole number? So 12 divided by 1 is 12, right? So yes. So 1, of course, it's always a factor. And also the number itself is always a factor. But there could be other factors in there. So, for example, what's the next number after 1? Well, that would be a 2. So you're asking yourself, is 2 a factor of 12? Well, let's see on the calculator. So all I have to do is just punch the number. So 12 divided by 2. Oh, it's a 6, right? So that's an integer. So yes, 2 is a factor and also 6 is a factor. So they kind of like when you find one, you find another one. So 2 is a factor, 6 is a factor. Okay, let's go up another. So 1, 2, next one is 3. Is 3 a factor of 12? Okay, let's check that out. 12 divided by 3. Yes, it's a 4. Okay, so the 4 is the answer. So 3 is a factor, 4 is a factor. But maybe I'm missing something there. So what would be the next one after 3? Well, that would be a 4, but 4 we already know it's a factor, so we're going to skip that. We go to 5. Okay, how about 5? Is that a factor? So 12 divided by 5. No. No, because I get like a decimal, right? 2.4. So you got to get an integer with no decimal part, right? Okay, so 5 is not, but 6 we already know, and 7 obviously will not, 8 will not, and so on. So that's basically all we've got, right? So nothing else. You mean you can try them out, but once you find 6 and a 2, right? And so 7, 8, 9, 10 will not work here because you're going to get some kind of fractional part. Okay, so that's it. So now let's deal with 26, right? Now we want to go through the same process. We want to list all factors of 26. Okay, so we always start with 1, and then we will end with the number itself, 26, okay? So that's always going to happen. So always do that. Okay, so now let's say we go to 2. Okay, so 26 divided by 2. What did I just do here? Okay, so that would be 13. Okay, yes. So 2 is a factor and also 13 is a factor. Okay, great. How about 3? Okay, let's try that. 26 divided by 3. No, it's not because I got a decimal part. So 3 is not a factor. Okay, how about 4? 26 divided by 4. Oops. 26 divided by 4. Okay, that's 6.5. Again, I get some kind of dot. See a dot, that's not good. It's not a factor. Okay, so 4 is not. 5 is not because in order for 5 to work, your number has to end with a 5 or a 0, and it doesn't. So that 5 doesn't work. How about 6? So we start kind of tedious here, but 6 will not work. 7, let's see if that works. No, it doesn't. Okay, so maybe 8. So you basically kind of keep going, and then you will see that nothing else is working here. Okay, so what else can work here? 9 does not, 10 does not, 11 so basically you start with all of these and then you don't see anything else. Okay, so you're gonna say, okay, well, there doesn't seem to be any other factors, so now I have to find the largest common factor. So first of all, let's circle the factors that they share. Okay, so the 1 and 1 they share, and 1 of course they always share. Okay, but maybe there's something else. Well, yes, there's something else, that's a 2. Okay, and nothing else they share, so that means that the GCF of 12 or 26 is 2. Okay, so we're gonna put it like this: GCF of 12 and 26 is equal to 2. Okay, now let's quickly look at the couple more examples. So 33, 15. So start with 1, end with 33. Okay, 33 is not divisible by 2 because it doesn't end with an even number. So we know don't even try 2, it's not going to work. 3, yes. So if you want to, by the way, know if a number is divisible by 3, you can always add the digits. So like 3 plus 3, that's a 6, and 6 is divisible by 3, so it's going to be divisible by 3. And that's going to give you 11. Okay, but I don't think anything else is gonna work. 4 will not work, as that's not gonna work, right? I mean, you can check it out if you don't believe me, but you're gonna see that there'll be all these integer parts. 5 will not work because the number has to end with a 5 or a 0, so that doesn't work. 4, 5, 6. So you can keep trying it, but you're not gonna find anything else other than 1, 3, 11. So for example, if you don't believe me, how about by 9? Divide by 9. No, it's not going to work, and so on. So you can try all of that, but none of them is going to work. Okay, how about 15? So 1, and we end with 15. Okay. 2 will not work because that's not an even number, but if I add 1 plus 5, that's a 6. So that is divisible by 3. So I think it's going to be divisible by 3, and that's going to be 5. Okay, so 3 is a factor, 5 is a factor. Is there anything else? Not really, because it's not going to be divisible by 4. The next one is a 5, but we already have a 5. So that's basically it. Those are all the common factors. So 1 is here, and 3. All right, so 3 is the greatest common factor. So we're going to say that GCF of 33 and 15, they share a 3 as a factor. Okay, how about 30 and 5? Okay, so let's try that. So 30. Okay, so by the way, 5 is what we call a prime number. So it only has factors as 1 and itself, nothing else. It's not divisible by anything else. But 30, what about 30? Okay, so it's definitely 1 and definitely 30. And because 5 only has two numbers, 1 and 5, so they can only share, either they share only 1, or maybe they also share a 5. So that's basically what we need to check it out. So if 30, we divide that by 5, that gives us a 6. So yes, so 5 and 6, those are two possible factors. Actually, 30 has other factors. For example, 3, it does have a 3 and it has a 10. But we're not interested in those because 5 only has 1 and 5. So what can they share? Only 1 or 5, right? That's it. So 5 is definitely GCF here. So GCF of 30 and 5 is 5. Okay. Now, here is another example, 13 and 8. So 13 is what we call a prime number. It means that there are no other factors other than 1 and itself. So you can check it out and you will see that 13 is not divisible by 2 because you got there some kind of fractional part. It's not divisible by 3 and so on and so forth. So nothing else works. How about 8? So okay, so start with 1 and with 8, okay? And then think of this. Do I have any other factors? Well, really, no, because even though, yes, I do, I actually have 2 and a 4, but we're thinking about what they share. So they don't seem to share anything because 13 only has 1 and 13 as factors, and 13 is definitely not a factor of 8 because larger than 8. So that's not possible. So the only factors that they share is 1. Okay, and if 1 is the only factor, then GCF that they share of these two numbers is going to be 1, and the numbers are called relatively prime. Okay, so because they don't share anything other than 1, and 1 is like not interesting because any two numbers, any two integer numbers will always share 1. So that's not interesting. So there is in a nutshell of how you would find GCF.